we know that slope equals the rate of change. So how do we graph when we're given a slope and a point? Well, this video is going to get into that. If you want to skip to some practice problems or some examples, that'll be in the description timestamp. But first, let's talk about some theory. So slope equals rate of change. So when we're given a slope, we're basically given a direction that the line is going to travel in. So we don't need an equation yet, but we're going to be given a point. So given a point such as 1 and 4. All right, we're given a point. So can a point make a line? No, but it can tell us where to start. So let's go ahead and do that. We're given the point 1 and 4. So we're going to go 1 to the right and 4 up. 1 and 4. So we were given a point. Well, that's somewhere to start. Let's also say that we're given the slope. And the slope in this case is going to be slope equals, in this case, it's going to be 3 over 2. This gives us a direction. The direction. Okay. So we know that slope equals rise over run. So what you see here, 3 over 2, is our rise over run. So this brings us right into our first example. So example 1 will be what we were given. So point 1 and 4, slope 3 over 2. All right, there's example 1. So given that, what do we do now? Well, we're going to graph this. We're going to find the line using our slope and 1 point. So if we know that our slope is 3 over 2 and slope is rise over run, let's just write that down. Then we know that this is your rise, and this is your run. So let's enact that from this point. We're going to run 2, 1, 2, and we're going to rise 3, 1, 2, 3. Okay. Then now we have everything we need to graph this line. Go ahead and connect them. I know it's far from a beautiful line. Let's start over. Go ahead and connect them. Okay. And now from point to point, it's going to repeat. Point to point, it's going to repeat in this pattern of running 2 and rising 3. And it's going to repeat again. Running 2, rising 3. All right, so that's one example. We'll go ahead and erase all of this, and we'll do another example. So now we're going to go ahead and get right into the meat of it. Example 2, we're given the slope. We're going to be given two things, the slope and a point. We're given slope -1 over 3 and point. We're given the point 4 and 2. All right. So now we have a negative slope and we're given a point. Let's go ahead and find our point first. 4 and 2. So 1, 2, 3, 4, and 2. Up 2. And that would be right there. Shade that in a little larger. Okay. Now we're giving ourselves a slope. So we see the negative sign. So the first thing we have to remember is, what does a negative slope look like? Well, a negative slope here in blue is, as it travels right, it travels downward. That's our negative slope. So how do we translate that? Well, what that means, and we also know that we have rise over run. So for every -1 we rise, we're going to run 3. So when I say -1, what we do is we sink downwards. So let's display that. What we do is we run 3, 1, 2, 3, and then we fall 1, because this is a negative slope. So we go down 1, and we'll be right about there. Okay. We shade that in a bit more. Okay, now we've graphed 2 points, so we're good to go. Now all we have to do is connect those 2 points, and we have our line. Let's move on to one final example. All right, example 3. We're given a slope. We're given a slope of 4, and we're given the point. We're given the point -2 and 1. All right. So how do you think we should approach this problem? Well, we have to use a fact. Any whole number can be expressed as a fraction, so don't let this slope that's a whole number confuse you. This slope of 4 is the same as 4 over 1, and we know that it's rise over run. So what that's telling us is that for every 4 we rise, we'll run 1. So let's start by go ahead and graphing our first point. Give us somewhere to start. We'll go 1, 2, and up 1. So right there, right about there. Right, let's shade that in a bit. Okay. And now our slope is 4. So that means for every 1 we travel over, we're going to travel up 4. 1, 2, 3, and 4. Right there. Now we connect those 2 points as best we can. Not perfect, but it gets the point across. We have a slope of 4. So for every 4 we travel up, we travel 1 over. For every -4 we travel over, we travel down 1. Sorry, for every 4 we travel down, we travel over 1. So that's example 3. I'm going to leave you with a set of practice problems for you to work on your own. So here we have 3 practice problems, each one represented by a different color. Go ahead, give these a try, graph them, sketch them, understand them, and I'm going to work through them myself. All right, let's get right to it. We're going to tackle this a little faster than I did the previous ones because I'm sure you understand rise over run at this point. So we have a slope and a point. Let's first graph our point. Our point is going to be at x equals 0, y equals 1. That's right here. So let's go ahead and put a nice visible dot right there. Okay, that is our first point. We're given a slope of 2 over 3. So for every 2 we rise, we run 3. So let's go ahead and run 1, 2, 3. And we're going to rise 2, 1, 2. And we are right about there. That's our 2 points. We can connect them and extend them beyond. All right, now we're going to the blue question. We're given the point 2 and negative 2. So let's go ahead and find that. 1, 2, down 2, 1, 2, and we are right about there. All right, let's shade that in nice and big. And what is our slope of this line? Well, is negative 3 over 1. Okay, so for every 1 we travel over, we're going to travel downward 3. So we go 1, then we go 1, 2, 3. Right about there. Pretty steep negative slope. So we're going to go ahead and connect those 2 lines there. Go ahead and connect them as straight as we can. Not perfect, but good enough. If you have graph paper, you can kind of make sure you're intersecting or use a protractor. All right, now number 5, we have a slope of 5. This is going to be a very extreme slope. We have the point negative 1 and 0. So we travel negative 1 in this direction and 0 in the y direction. So there we are. We're going to shade that in nice and big so we can see it. We have a slope of 5. So for every 1 we travel over, we're going to travel up 5. So that tells us when we travel over 1, we land right at the x equals 0. We travel up 5. So we can just go ahead and pop right on up here to where the tick mark for 5 is. And we shade that in nice and visible. And now we're gonna connect those 2. It's quite an extreme slope here. Quite an extreme slope. And that's our 3 examples plotted. So this has been Graphing with Slope. If you got anything useful from this video, like, subscribe, leave a comment. Thank you for watching.